Hi students, welcome for another session of our class 9 maths chapter 2 polynomials and factorization. So what is meant by polynomial first of all? A polynomial is an algebraic expression in which the variables involved should have only non-negative integral powers. What is meant by polynomial? The definition of the polynomial is nothing but here. An algebraic expression in which the variables involved the algebraic expression may contain number of variables, maybe one variable or two variable or three variable, number of variables may be consist. All the variables must have only non-negative integral powers. Involved should have non-negative. Non-negative means only positive. Non-negative integral powers. An algebraic expression in which the variables involved should have only non-integral powers are called algebraic expressions in which the variables involved should have only non-negative integral powers are called polynomials. For example, let us take algebraic expression 2x square plus 5x minus 7. It's an algebraic expression. The variable which is involved, what x is the variable in it. The exponent of the x here is 2. The exponent of the x here is 1. Here the exponent of the x is 0. That is why variable is not there. It's a constant term. This is a polynomial in x. So we can denote it as p of x. It's a polynomial in variable x. Suppose if I take 4y cube minus 7y square plus 5y minus 9. It is also an algebraic expression containing the variable y, and the variables of the variables integral powers you see negative or non-negative. It's a non-negative. Plus 3, plus 2, here plus 1, here the variable power will be 0. That means the exponents of the variable should have only positive integrals. Then only we can call it as polynomial. This is the polynomial in variable y. P of y is equal to 4y cube minus 7y square plus 5y minus 9. Like that. For example, one more algebraic expression I will take now. 2x cube minus 4 by x plus 7. If I take like this, here the first term of this what 2x cube, the variable is x, its exponent is minus 3 here, but 4 divided by x. Here the exponent of the x, if you take it up, it will become negative integer. That is why it is not a polynomial. Why? Here the degree of the variable is plus 3. Here the degree of the variable will be, when you take this variable in the numerator, it becomes negative. Then you cannot call it as a polynomial. That means variable should not be in the denominator. If the variable is in the denominator, if you bring it up, the variable exponent will become negative. Already we have given the definition. Then algebraic expression which has only non-negative integral variables, then only we can call it as polynomial. So this is not a polynomial. Why? The reason is that x, the variable is in the denominator place. The variable should not have the denominator place. It should be having compulsory positive integer as its exponent. Then only it will become a polynomial. Polynomials are of different types. Polynomials are classified as based on the degree of the variable and based on the number of terms. We have different types of polynomials: monomial, binomial, trinomial, polynomial or multinomial. How these are named? Based on the number of terms. If a polynomial contains or an algebraic expression contains only one term in it, it is called monomial. If there are two terms in it, it is called binomial. If there are three terms in it, trinomial. If there are more than three terms, it is called multinomial. All these are polynomial only. These names are given according to the number of terms involved in it, and according to the variable's degree. According to the variable's degree also, polynomials are classified into another names: linear polynomial, quadratic polynomial, cubic polynomial, fourth degree polynomial, fifth degree polynomial, nth degree polynomial. What is meant by degree? The variable which is involved in the algebraic expression, its exponent should be positive integer. We already said that. That positive integer what? Is it 1 or 2 or 3 or 4 or 5? Based on the number of the exponent. The exponent, if it is 1, it is called linear polynomial. If the exponent is 2, it is called quadratic polynomial. If the exponent is 3, it is called cubic polynomial. If the exponent is 4, it is called fourth degree polynomial. If the exponent is nth degree polynomial. So polynomials are classified based on the number of terms and based on the degree of the variable. We are giving different names for the polynomials. Let's see what are the different types of polynomials classified based on the number of terms and based on the degree of the variables. See, classification of the polynomials. Polynomials based on the number of terms and polynomials based on the degree of the variable. We will have different types of polynomials. Let's see polynomials based on the number of terms. First, let us take monomial. What is mean by monomial? Monomial means the number of terms in the polynomial should have only one term. The algebraic expression which has only one term in it called monomial. Monomial will have only one term. Only one term. For examples, suppose 2x cube, minus 3y to the power of 5 plus otherwise 9p square. These are all single terms. Suppose if I write 4xyz, of course there are three variables in it, but there is only one term. Only one term. See here, next one, binomial. Binomial means there will be how many terms? Only two terms. Two terms. An algebraic expression with two terms is called binomial. For example, 2x square plus 3x minus 5x plus 7 3x square plus 5, like that. There are only two terms. Maybe number of variables how many, but the terms, how can you define the terms? This is one term, this is one term, this is one term, this is one term. This total is only single term. These are two terms. These are two terms. Algebraic expressions which number of terms we are classified polynomials. Only one term is there, that is called monomial. There are two terms, it is called binomial. If three terms, it is called trinomial. Trinomial. The number of terms in it will be three terms. 5x square plus 7x minus 5. See, there are three terms. 1, 2, 3. Three terms. Suppose 4k cube minus 5k square plus 7. There are three terms in it. 1, 2, 3. So like this. So number of terms, based on the number of terms, polynomials are classified as monomial, binomial, trinomial and multinomial. If more than three terms, it is called multinomial. If more than three terms are there, that is called multinomial. multinomial. More than 3 terms. Here how many terms are there? 3 terms. Like that. Now these are the different names based on the number of terms in the algebraic expression. Now in this, polynomials based on the degree of the variable. First one is linear polynomial. Linear polynomial. That means the algebraic expression in which the variable exponent should be only one. The variable's exponent should be only one. Then only it is called as linear polynomial. For example, degree should be how much? Degree should be equal to 1. The variable's degree should be 1. Then only it is called as linear polynomial. For example, 5x minus 7k seven p plus 5. There are two terms in it, but what is the variable? P is the only variable. Its exponent is 1. Here k is the variable, its exponent is 1. Here x is the variable, its exponent is 1. The algebraic expression in which the variables involved should have its degree as 1. Degree means the exponent should be 1. The highest degree should be 1. Then it is called as linear polynomial. Second one, quadratic polynomial. Quadratic polynomial. The polynomial in which the variable involved should have its degree only 2. The highest degree should be 2. Then only we call it as quadratic polynomial. Degree should be how much? 2. Second degree polynomials are called quadratic polynomial. For example, 3x square plus 4x minus 7. Here there are 3 terms. Number of terms doesn't matter here. Here the degree of the variable. What is the variable? It is x is a variable. Its degree here it is 2, here it is 1, here it is 0. But the highest degree in the entire expression is what? 2 only. So it is a quadratic polynomial. Suppose minus 5p square plus 7p minus 8. It is also a quadratic polynomial. Why? The degree of the variable p is 2. That is why it is called a quadratic polynomial. So degree of the variable is 1, it is linear. Degree of the variable is 2, it is quadratic. If the degree of the variable is 3, it is called a cubic polynomial. Cubic polynomial. Degree of the variable should be 3. The degree of the variable should be 3. For example, 4x cube minus 5x square plus 3x minus 8. See, what is the variable in it? X is a variable. The degree of the variable is 3. So it is called cubic polynomial. Another example you can take minus 5k square plus 7k cube plus 8. Here number of terms are only 3. What is the variable? K is a variable. The degree is here 2, here it is 3. Highest degree of the variable should be 3. Then only it is called cubic polynomial. If the degree is 4, fourth degree polynomial. If the degree is 5, it is fifth degree polynomial. If the degree is n, that is called nth degree polynomial. Actually, whatever the degree is there, with that degree we name as a polynomial. First degree polynomial is called linear polynomial. Second degree polynomial is called quadratic polynomial. Third degree polynomial is called cubic polynomial. Then afterwards, whatever the highest degree is there, with that name only we will call it as a fourth degree polynomial, fifth degree polynomial or sixth degree polynomial. If the degree, highest degree of the variable is n, that is called nth degree polynomial. Here the degree and the number of terms also have a relation. If the degree is 1, the polynomial will have at most 2 terms. At most. That means more than 2 is not possible. If the degree is 1, it is called linear polynomial. A linear terms. It is not compulsory to have 2 terms, but not more than 2 terms. It may be only a single term also. 2x square or 5x square or 5p square if I write. The degree of that variable is 2, but the term is only 1. No problem. What many terms are there doesn't matter, but the degree is matter to say the polynomial is linear or quadratic or cubic or 4th degree or 5th degree or nth degree. To say how many terms exist for a linear polynomial means degree is 1. At most 2 terms will be there. If nth degree polynomial is there, what will be the number of terms maximum? N plus 1. If the degree of a polynomial is n, the number of terms maximum will be n plus 1. Understand? I hope you all understood the classification of the polynomials. What is meant by polynomial? An algebraic expression in which the variables involved should have only non-negative positive. Non-negative means that is positive integral powers. That means the variable should not have negative integers as exponents. If the variables have negative integers as exponent, it does not called as a polynomial. It may be an algebraic expression, but it is not called as a polynomial. Whatever the variables involved in an algebraic expression, that all the variables should contain only positive integers as their exponents. Then only that algebraic expression is called a polynomial in which the variable is involved. If all the variables are x only, that algebraic expression is called polynomial in x. If the variables all are k, that algebraic expression is called as polynomial in k. Only thing you need to remember, the variable's exponent should not be negative. The variable's exponent should be only positive integer. Then that algebraic expression is known as polynomial. Polynomials again classified into different names based on the number of terms involved in it, based on the degree of the variable involved in it. Polynomials are named differently. Based on the number of terms, polynomials are named as monomial, binomial, trinomial, monomial. What is meant by monomial? If the number of terms are only 1, that is called monomial. If the number of terms are 2, that is called binomial. If the number of terms are 3, that is called trinomial. If the number of terms are more than 3, that is called multinomial. Based on the number of terms, polynomials are named as monomial, binomial, trinomial and multinomial. Monomial, only single term. Binomial, 2 terms. Trinomial, 3 terms. Multinomial, more than 3 terms. This classification is based on number of terms involved in it. Again, polynomials are named again as linear polynomial, quadratic polynomial, cubic polynomial or 4th degree polynomial, 5th degree polynomial or nth degree polynomial. How we are classifying these polynomials as linear, quadratic and cubic? Based on the variable's exponent, that means the degree, highest degree of the variable in an algebraic expression. If only variable have only one as highest degree, that is called a linear polynomial. If the highest degree is 2, that is called a quadratic polynomial. If the highest degree is 3, that is called a cubic polynomial. If the highest degree is 4, 4th degree polynomial. If the highest degree is 5, 5th degree polynomial. If the highest degree is n, nth degree polynomial. Now, degree and the number of terms also have a relation. Whatever the degree is there, the degree how much is there? At most, that degree plus 1 number of terms will be there. If the degree is 1, that is called a linear polynomial. A linear polynomial degree is 1. That linear polynomial will have at most two terms. Single term also possible, 2 terms also possible, but 3 terms does not exist. Next, quadratic polynomial. How do you name it as quadratic polynomial? If the variable's exponent is 2, that is called quadratic polynomial. Quadratic polynomial means the degree is 2. That quadratic polynomial at most it will have three terms. More than 3 is not possible. It may have only single term, it may have 2 terms, it may have 3 terms, but not more than 3. At most 3 terms only. If the degree is n, it may have 1 term, 2 term or 3 term or n terms or n plus 1 term, but not more than that. Hope you all understood what is called polynomial. How do we classify polynomials based on the number of terms, based on the degree of the variable. This is what introduction for the polynomials. Let us get into the exercise 2.1, in which the given algebraic expressions are polynomials or not. Let us check. Say exercise 2.1, first question. Find the degree of each of the polynomials given below. There are some polynomials are given. We have to identify what is the degree of the polynomial. How to identify the degree of the polynomial? We have to check out the variable and its exponent. How many terms are there? In all the terms, check the variables. What are the exponents of the variable? Whichever the highest exponent is there, that will become the degree of the entire polynomial. See the first one, x to the power of 5 minus x to the power of 4 plus 3. There are 3 terms in it. X to the power of 5 minus x to the power of 4 plus 3. There are 3 terms in it. In first term, what is the exponent of the variable? 5. In the second term, what is the variable of the exponent? Here 4. Third term, what is the exponent of the variable? Here variable is not there, only constant term is there. That means the variable's exponent is 0. Understand? Here the exponent is 5, here the exponent is 4, here the exponent is 0. You cannot see the 0. That means here x to the power of 0 is there. If any variable, if the base, whatever the base is there, if the exponent is 0, that value becomes 1. We all know in the previous classes we have learned exponents and powers. So here 3 means here it is a constant term. In this, the variable's exponent is 0. Here the exponent is 5, here the exponent is 4, here the exponent is 0. What is the highest exponent? 5. So that 5 will be the degree of this entire polynomial. So its degree is what? Degree is equal to 5. See the next one, x square plus x minus 5. What is the variable in this polynomial? X is a variable. Its degree in the first term is 2. Its degree in the second term is 1. Its degree in the third term is 0. But what is the highest one? 2 is the highest exponent of the variable x. So this will become the degree of this polynomial. So for this, the degree of this polynomial is what? 2. Here you see the third one, there is no variable at all. There is no variable at all. This is called constant polynomial. Why? Because the variable is not there. The variable, if it is there, its exponent is 0. That is why you cannot see the variable. Here 5 is there, means you can keep any variable, but the exponent of that variable is what? 0. That is why the degree of the constant polynomial, always you should remember, degree of the constant polynomial is 0. Here there is no variable, that is why degree of this polynomial is what? 0. For a constant polynomial, what is the degree? 0. Next, see 3x to the power of 6 plus 6y to the power of 3 minus 7. Here there are 2 variables involved in the algebraic expression. There are 2 variables in it. In the first term, what is the variable? X. In the second term, what is the variable? Y. The third term, there is no variable at all. The first term, x variable is there. In the second term, y is a variable. In the third term, there is no variable at all. But what is the exponent of the variable in the first term? 6. What is the exponent of the second term? 3. What is the exponent of the variable here? Variable not there. That is why exponent will be the 0. Here, highest degree is what? 6 is the highest degree. That is why the entire polynomial's degree will become 6. So degree of this polynomial is what? 6. Next one, 4 minus y square. The first term is the constant term, second term is y square. Here what is the variable involved in it? Y is the variable. This is the polynomial in y. That variable has the degree 2, that is the highest degree. So that will be the degree of the entire polynomial. So here degree is what? 2. Next, see the last one, 5t minus square root of 3. Here what is the variable? T is the variable. First term consisting a variable t, second term there is no variable at all. But the first term variable t has exponent nothing, that means 1. Here you cannot see the variable exponent is 1. There is no exponent, means you have to imagine it as 1. So the degree of this polynomial is what? 1. given, we have to observe all the terms, whatever the variables are involved in it, and what are their exponents. The highest exponent value only becomes the degree of that entire polynomial. Hope you all understood how to write the degree of a polynomial. Let us see second bit of this exercise. See question number 2. Which of the following expressions are polynomials in one variable? Here some algebraic expressions are given. Whether they are polynomials or not, how many variables? Okay, we have to identify only the polynomial which has only one variable. If not, it is not a one variable. Like that we have to use the reason also. Why it is not a polynomial? We have to use the reasons also. So see the first expression, 3x square minus 2x plus 5. Here what is a variable? X is a variable. In all the terms only one variable is there, which is x. So the degree of the variable, how to check? The degree of the variable should be positive integer. Positive integer. Then only that expression is called a polynomial. Yes, the variable is the degree, that is the exponent of the variable is 2, which is positive integer. So it is a polynomial. It is a polynomial. Yes, it is a polynomial. It is a polynomial. In one variable. What is that? In variable x. In one variable. That is what? X. In one variable x. So it is called a polynomial in variable x. So next one, x square plus square root 2. X square. What is the variable? X is a variable. The degree of the variable is 2, which is positive integer. And there is no other variable involved in this expression. So it is also a polynomial. Yes, it is a polynomial in one variable. In one variable x. Next one you see, p square minus 3p plus q. The first term variable is p and its degree is 2. Second term variable is p, its degree is 1. Third term variable is q. That means this entire expression consists of two variables. It consists of two variables. So it is not the polynomial in one variable. Reason what? There are two variables in this expression. No, it is not a polynomial. No, because it has two variables in it. What are the two variables? P and q. It should be only one variable. In the all terms should contain same variable. But in the first term variable is p, second term variable is p, but third term is q. So there are two different variables are there. What is the question actually? Which of the following expressions are polynomials in one variable? Here there are two variables in this expression. That is why we are writing it as no. No, because it has two variables. Two variables, p and q. There are two variables involved in this expression. That is why it is not a polynomial in one variable. Of course, the degree of the first term is positive integer. Degree of the second term also positive integer, degree of the third term also positive integer only. But there involve two variables. That is why we are writing it as no. Next, the fourth one. Here first term is what? Y plus second term is 2 divided by y. The variable is only one. What is that? Y. But the variable in the first term, the degree of the variable is 1. Second term, whereas the variable is in the place of denominator. When you bring it up, the variable's degree will not be the positive one. It will be the negative integer. So that is why it is not a polynomial first of all. Why? Because the variable y is in place of denominator. So the variable should not have in the denominator place. Why? When you bring it out, the variable's degree will become negative integer. That is why it is not a polynomial. No. Because the variable y has a negative Here you cannot say negative integral power. How can you say it is negative integer? Because the variable is in the denominator place. When you bring it up, it becomes negative integer. You already learned the exponents and powers in your previous classes. 1 by a to the power of m will be equal to a to the power of minus m. That means the integer, when you bring it up, its exponent becomes negative. The variable which is in the denominator, when you bring it up, the variable's exponent becomes negative. That is why it is not a polynomial. To say it is a polynomial, all the variables should be having only non-negative integers as their powers. Here, the variable y is in the denominator's place. That is why it is not a polynomial. First of all. Next, find square root of x plus x into square root of 5. Of course, the variable is only one variable. Here also x, here also x. But the first term, the variable x is inside the square root. The inside the square root means the exponent of that x will be 1 by 2. Root x can be written as x to the power of 1 by 2. That 1 by 2 is not an integer. That 1 by 2 is not an integer. Integers are what? Positive integers, negative integers. Or do not have any decimals, do not have any fractions in it. Integers means 0, plus 1, 2, 3, 4 and minus 1, 2, 3, 4, so on. But to say polynomial, it should have integers and that too positive integer only. First of all, it is not an integer. The exponent of this variable in the first term is not an integer. Under root of x is there. The under root of x, if you write as exponential form, the exponent of the variable will become 1 by 2. So that 1 by 2 is not a integer. That is why it is not a polynomial. No, because the variable x power is not an integer, It is a rational number. 1 by 2 is a rational number actually. It is not an integer. Where is 1 by 2? You cannot identify the number 1 by 2. Here the exponent of this x is 1 by 2. How you got that 1 by 2? Because the variable is inside the square root. This square root, if you write in the exponential form, x to the power of 1 by 2, it will become. That 1 by 2 is not an integer. That is why it is not a polynomial. Next one. See, first term is x to the power of 100 plus second term is y to the power of 100. There are two variables involved in it. Of course, the degree of the variables are positive integers only. The 100 is positive integer. The exponent of x is 100, the exponent of y is also 100. Both are positive integers only. But the question is, the polynomial should have only one variable. Here, x and y, there are two variables. That is why it is not a polynomial, one variable. No, because it has two variables. It has two variables. X and y. That is why this is not a polynomial. To say an algebraic expression is a polynomial in one variable, all the terms should contain only single variable which is same. And the degree of the variable, the degree means the exponent of the variable should be integer, that too positive integer. There should not be any negative integer and the variable must be in the numerator's place. It should not be in the denominator's place. If the variable is in the denominator's place, when you bring it up, the exponent of the variable becomes negative. That is why it is not a polynomial in this condition. So like that, the second bit, we have identified which are the polynomials in one variable, which are the not polynomials, what are the reasons behind to say it is not a polynomial. We explained clearly. Hope you all understood. With this, our session concludes. We will meet in the next session to continue the exercise 2.1. Thank you.